Today's lesson is about best fit regression line. We can use the graphing calculator to find the best fit regression line. Also, we can use this formula to figure out the best fit regression equation. Here, S sub xy means a covariance. S sub x, that means the standard deviation of x. S sub y means the standard deviation of y. How to draw a line of best fit? First of all, you need to calculate the mean of x and y. Mark the mean point. Draw a line through the mean point, which fit the trend of the data, and so that about the same number of data points are above the line as below it. Interpolation and extrapolation. Look at this diagram. This line is a line of best fit. We have a maximum x value and a minimum x value. Between this minimum and maximum x value, any data between minimum and maximum, we call that interpolation. So if your x value is less than minimum value or greater than the maximum value, we call that extrapolation. When you predict a y-value from x value, the accuracy of an interpolation depends on how linear the original data was, but the accuracy of an extrapolation depends not only on how linear the original data was, but also on the summation that linear trend will continue past the pose. Let's go to guided practice 1. The following table gives the height and weight of a 16-year-old boy. A. Find the mean height and the mean weight. Before you rush into that stat, edit L1, L2, check this grade. They put the weight as x-axis and height as y. Therefore, for L1, you have to put the weight. L2, you have to put the height. Don't mess this up. And then we go to calculate. Go to two variable statistics. You can get the x. That's the mean weight. It's 68.4 kilogram. For the mean height, it will be 177 centimeters. For B, plot the above data on the grade below and draw the line of best fit. We know, first of all, that's 73, 182. 73 is over here, 182. We already plot this point on this grade. But when you draw the line of a best fit, you have to make sure do the mean point. The weight is 68.5 and the mean height is 177. The red is the mean point. Then you draw a line passing through this mean point. This is the line of best fit. Now let's go to C. Use graphing calculator to find the coloration coefficient R and describe the stress and direction of the coloration. Make sure you put the diagnostic on. According to the given information of B, we know the L1 will be the weight and L2 is the height. Then you go back to stat, go to calculate, go to 4, linear regression AX plus B. Then you will get this. We put the L1 for X, L2 for Y, then store the regression equation in Y1. So that is when we predict the value, it will be easier. Then put the enter, you will see this is the correlation coefficient. So we get the R equal 0.943. Remember, 3 significant figures. How to describe the correlation? It will be high and a positive correlation between weight and height. Then for D, find the equation of the best fit regression line. We already got this, y equals. So we write down y equals 1.66x plus 63.6. Look at the E. Use the regression equation to find out the height when a 16-year-old boy is 70 kilograms. We have 2 ways to do that. One way, we just plug in this equation. So we get the y equals 1.66 times 70 plus 63.6. You will get answer 179.8 centimeters. Or you can go to calculator. We just do y1 for 70 equal 179.651 and so on. Either way will be fine. That's the reason we restore regression equation in this y1. For F, use the regression equation to find out the weight when a 16-year-old boy is 185 centimeters high. So we plug in y equals 185 equals 1.66x plus 63.6. So we minus 63.6, then you divide it by 1.66. You will get the x equals 185 minus 63.6 over 1.66. So you will get x equals 73.1 kilogram. Let's go to guided practice 2. This table shows the weight and cost of candy bars. Given standard deviation for X is 19.2, for Y is this. For covariance is 5.81. Find the correlation coefficient. We know that R equals covariance over standard deviation for X and then standard deviation for Y. So we plug in 5.81 19.2 times 0.307. We put into calculator, you will get equals 0.986. So it has a strong or very high positive correlation. If you put the data into calculator, then you do the linear regression, you will get y equals 0.0158x plus 0.182. For D, use your equation to estimate the cost of a candy bar weighing 109 gram. You can use calculator, get 1.90. Remember the unit is euros. Or you can just plug into 109 here. Then put into calculator. You will get the same answer, 1.90 euros. Now let's go to guided practice 3. A teacher asked the 5 students how much time they spent preparing a speech. The results are shown in the table. Along with the grade awarded to the students, draw a scatter diagram to illustrate this data. Since our data for x is 1 through 7, we can just do 1, 2, 3, 4, 5, 6, 7. For the grade, that's the lowest one is 65. So I can do 65 here. Then you do 70, 75, 80, 85, 90, 95. This part is a grade, and this one is hours. Now let's plot the points here. Now already finished drawing a scatter diagram to illustrate this data. Now let's go to B. Use graphing calculator to find the correlation coefficient R. First of all, make sure your calculator put the diagnostic on. Then you put the preparation and the grade into L1 and L2 separately. Then we do stat calculate, go to 4. Restore regression equation in Y1. You are given this linear regression equation and also this R. So R equals 0.881. Remember, use 3 significant figures. Describe the stress and direction. You could say this is a high positive because it's a positive. It's not, this number is positive. So we say it's a high positive correlation between preparation time and the grade. Use the following formula to find the equation of a best fit regression line. We call this is a standard deviation, but from the calculator, remember we use this sigma. You go to stat, calculate, go to 2 variable statistics, then you put enter. You are given the mean and also the sigma notation, that's a standard deviation. For the y, we are given the mean and also this sigma y means a standard deviation for y. Therefore, we plug in y minus 81 equals 0.881 times standard deviation for y, that is 10.7. Standard deviation for x, that is 2.01. Then we do x minus mean for x, that's 4.1. 4.69 x minus 4.1. Then we do distributive property here. You will get 4.69x. 19.2. Then both sides we add 81. So you will get the y equals 4.69x plus 61.8. This will be the equation of best fit regression line by this formula. Now let's go to E. Use graphing calculator to find the equation of a best fit regression line. It's over here. A equals 4.68 and B equals 61.8. So we write down Y equals 4.68x plus 61.8. Now let's go to J. Use the regression equation to estimate the grade if one student prepare a speech for 2.3 hours. You are given the regression equation by graphing calculator. So we get Y equals 4.68 times 2.3 plus 61.8. You will get 72.6. For 8, use the regression equation to estimate how much time one student prepare a speech if his grade is 73. So we set up 73 equals 4.68x plus 61.8. Subtract 61.8, then you divide by 4.68. You will get the x equals 73 minus 61.8 over 4.68. You will get the x equals 2.39 hours.